third year students, let us talk about complex integration today. If a function fz is analytic, then its indefinite integral is same as the real valued function's integration. That means integration fx dx, if integration fx dx is equal to capital Fx, then ddx capital Fx is equal to small fx. This is applicable for the real valued function. But in case of complex valued function, if the function is analytic, the same process, integration fz dz. If the function is analytic, then the same rule which is used in the real valued function is applicable for the complex valued function. But in case of definite integral, it has a different norm. As you know, for the real valued functions, in case of definite integral, if we describe here one thing, here capital Fx is the antiderivative, and if we differentiate the capital Fx, we can easily find the original function. For the real valued function, integration a to b fx dx or integration a to b fy dy. These two are for real valued function. Here the limit is x is equal to a to x is equal to b along the x-axis, and here the limit x is y is equal to a to y is equal to b along y-axis. But in case of complex function, specifically the analytic function, the integral will not be along x-axis or y-axis. The integral will be along a curve. See, say this is a curve A and B. If we name this curve C, then the complex integral will be integral along C fz dz or integral a to b fz dz. This kind of integration or this kind of integral is called line integral or integration along any specific curve. So this is about the complex integration. Now we are to talk about some theorem. Let me discuss some basic theorem on complex integration. First one is the Greens Theorem. in plane. Here the plane is two-dimensional, which will be if pxy and qxy be continuous partial derivative, be continuous and have continuous partial derivatives in a region R or on the or on its boundary C, then integral along C p dx plus q dy is equal to double integral R del q by del y, del x minus del p by del y dx dy. So this is a basic theorem on complex integration, which is called Greens Theorem in plane. It says if p and q be two continuous functions, here p and q are functions of several variables. These two functions are to be continuous and have continuous partial derivatives in a region R, a particular region R, or on its boundary C, then integral along C. This is to be read integral along C. Along C means along the curve p dx plus q dy is equal to double integral, which is called surface integral as well, you know. Double integral R is the region, del q by del x minus del p by del y dx dy. So this is the Greens theorem in plane. Another basic theorem is Cauchy's theorem or Cauchy's integral theorem. The Greens theorem, I think you are familiar with the Greens theorem from earlier classes. Now we will be talking about Cauchy's theorem or Cauchy's integral theorem, which is very, very relevant and important for complex integration portions. The statement, let me discuss the statement first. Statement: if fz is analytic, we know what is called an analytic function, is analytic in a region R and on its closed boundary, I mean, say, let me draw a picture. Say this is a region R. If we name this curve C, that the region confined by this curve is R and the boundary is C. So if fz is analytic, if a function fz is analytic in this particular region R and on its boundary means the border line here C with derivative f prime z which is continuous at all points inside R and on C. So let me review what the fundamental integral theorem, which is known as Cauchy's integral theorem or simply Cauchy's theorem, states. The statement is, if fz is analytic in a region, in a particular region R and on its boundary, not only in this region but also on its boundary as well, with derivative f prime z, that means this function fz is analytic inside R or on its boundary, which is continuous at all points inside R and on C, then integral along C fz dz is equal to 0. So this is a prominent theorem which says if a function fz is analytic on a particular region and on its boundary, then the integral along C, if we take integral along the curve, then the value will be 0. This is the Cauchy's fundamental theorem or Cauchy's integral theorem. We will be proving this theorem in our next class. So please start studying complex integration portion. It's very interesting. I think you have the basic idea of integration regarding the real valued function. The process is same, but the basic difference is the definite integration of complex function or analytic function. It should be along a curve integral, or simply called line integral along a particular curve of a complex function or analytic function. So we will be proving this theorem in our next class. We have some more important theorems to be discussed, and then we will be solving some integrals. So till then, stay safe. Thank you.